Hi, I'd like to prove that cos of a plus b equals cos a cos b minus sin a sin b. So the main part of this video is to prove it from the equation of sin a plus b. But what I'll do actually, I'm going to very briefly show you the sin a plus b proof, because I've actually just done another video of it. So if you wanted to have it maybe in a little bit more detail, watch my other video. But for completeness, I'll show you the sin plus a one. Sorry, the sin a plus b sheet for that in the diagram. And then I'll quickly move on to the one, starting from the sin and then showing the equation for cos a plus b. So to prove sin a plus b is sin a cos b plus cos a sin b, I did the video, so I made this diagram. Actually, incidentally, you can use the same type of diagrams to prove the cos a plus b just using similar geometry, but obviously you'd have different labels and different arrows. So you'd start off with the two triangular segments, you pull one of them out just to adjust them, and then you get the two heights, h2 and h1, cos b, and then from that, this is just a very quick overview, then the sin a plus b is sin a cos b plus cos a sin b. So it's all from that diagram that I've done another video on, and you could actually, but you'd obviously need extra labels. You could label them up differently to prove it for cos. But what I want to do is I want to start off with the equation for sin a plus b, and then from that show you the equation for cos a plus b. So what I'm doing then is I'm saying cos a plus b, it's the square root of 1 minus sin squared a plus b. So what I'm doing then, so it's square root of 1 minus, and then the expansion of sin a plus b all squared. The expansion being the one that we just showed a minute ago from the other sheet, but I've got a more detailed video on. So that's that previous function squared. So when I expand that, because it's 1 minus basically the a plus b squared, everything afterwards becomes minus. So it's 1 minus sin squared cos squared b minus, of course, twice the product, 2 sin a cos b cos a sin b minus cos squared a sin squared b, and then take the square root of the whole lot. And then what you do is, so the one at the beginning, if we rewrite that as cos squared a plus sin squared a, then we just have the original terms that we subtract from the sin squared a cos squared b minus 2 sin a cos b cos a sin b minus cos squared a sin squared b, as we had from last time. So what we do then, we take first of all take the cos squared a and then group all the cos squared a's together. So I've got cos squared a on its own, and then a cos squared a, or minus the cos squared a sin squared b. So that's the same as cos squared a 1 minus sin squared b. Do the same thing for the sin squared a. I've got a sin squared a, and then, or just after that, I've got the sin squared a cos squared b. So then I've got the sin squared a as a common factor, 1 minus cos squared b, and then as before, I've just got this minus 2 sin a cos b cos a sin b. So we don't really touch that. So we've got cos squared a 1 minus sin squared b. So another way of writing that then is cos squared a cos squared b. Similarly, I've made a mistake. Oh yeah, sorry, I've made a mistake in that the signs. I'm sorry about that. I've had to just correct. I've just noticed, as I was doing the video, just noticed a mistake I'd made. So just backtracking, I'd grouped the sin squares together to make a sin squared a 1 minus cos squared b. And another way, and then of course that was minus twice the 2 sin minus twice the sin A cos B cos A sin B as we've had before. And another way of writing 1 minus cos squared B, in that it's actually sin squared B, but I'd actually written cos squared. So what I did was I stopped the last video. I've corrected it in pen to make it sin squared B. So the term then is cos squared A cos squared B plus sin squared A sin squared B, and then subtract 2 cos A cos B sin A sin B. And of course, and then the square root of it. So that term is actually the square, because that term itself would be the square of cos A cos B minus sin A sin B. So because we've taken the square root of it, we actually end up with cos A cos B minus sin A sin B. So then we know that cos A plus B then is cos A cos B minus sin A sin B. Okay, so thanks for watching this video. Hope you enjoyed it, and good evening.